welcome to our next BSV Wales meetup. This is still an online event for obvious reasons, but we're hoping that tonight we can actually bring you really quite a special one. So as you can see, the event is focused on the concept of mining, and this is, as many of you will be aware, is one of the most fundamental aspects of how Bitcoin works, how the network is secured. But it's an industry that has for a long time been kind of single purpose and has been associated with just kind of providing hash power for the network. But tonight I'm hoping that we are going to have two talks from our some real experts actually, who are going to kind of open our eyes a little bit to some of the other things that happen and other kind of services that can be provided by miners. So the rough structure of the evening is this. So the first, there's going to be a short introduction to me. I apologize, those times are slightly wrong. The first talk is going to be from Jerry Chan from TAL on some particular service provision that he is looking to provide with his mining operation. And then we have a talk from Paul Webb, who is based in Cardiff and has a number of companies, including a data center called Clearstream Technologies, and he's going to talk about how he's branching out into Bitcoin and looking to again be a service provider, but also doing some very interesting things in terms of gaining additional efficiencies for his operation. So yeah, these are our two speakers, and I think it's going to be a very interesting evening. Please, just some housekeeping as we go. So you'll be able to submit Q&A in the Q&A function on the side here. So if you have any questions, please submit them in there, and then at the end of each of the two talks, we can put those to the speaker to hear their views. But without further ado, I'm going to hand over now to our first speaker, Jerry Chan, and I really appreciate Jerry being here, given that I think it's in the small hours where he is right now. So thanks very much for giving us your time. So I'm going to hand over now control to Jerry Chan from TAL to talk about the resolution of the Bitcoin tokenization experiment. Take it away, Jerry.
Hi there. Thanks, Jack. I hope everybody can hear me. If not, just give me a wave on one of these question channels. Thanks, Jack, for the great introduction. Today, I'd like to do a quick sort of short summary of TAL and as a transaction processor, and or what most people think of as miners, and a little bit about what our business is, what we do, and where I think a big part of this industry is going to move towards, which involves transaction processors and miners specifically. So, and I know that the title there on the slide is quite a bold statement, and I hope to be able to answer a lot of why that title is aptly chosen later in my presentation. So I'm going to share my screen. So just quickly off the top, we're a publicly traded company. Our ticker symbols are down at the corner there. We're traded on the Canadian Securities Exchange, the Frankfurt Exchange, and the New York OTC markets. And TAL was, I suppose, what was a traditional. I think initially the idea when Squire Mining was acquired was to build some ASIC chips for mining, and that changed to becoming just a dominant and large hash producer. And finally, our business model with me joining the firm and taking charge of changing the strategy to something more long-term sustainable. Earlier this year, in April, March, we've moved to something where we call transaction processing. So I can describe that more coming up. So what is blockchain infrastructure? TAL is a blockchain, or Bitcoin specifically, an infrastructure provider, vertical infrastructure provider, focusing mostly on enterprise clients. And what that means, in order to understand that, first we have to understand what the Bitcoin network really is, and before we can talk about its infrastructure. So on the right-hand side, you see this sort of this network that looks like a double sphere. projected in a two-dimensional plane anyway. And that's what the Bitcoin network really looks like. You may see this shape echoed in many presentations, some by Craig, some by others, and it usually goes by the name of a Mandela network. What it is effectively, without going too much into detail in this presentation, but the important part is that in this network, it's really two-layered. What's more than two layers, but for some, if you simplify it, there's the inner core layer, which is the layer of Bitcoin nodes, and those are the orange circles you have there. And that layer is where what you normally think of as the miners lie. And then the outer layer around that is sort of the application services layer, like the exchanges, the folks who need to run some sort of specific application service. It could be an exchange, it could be a specific business that runs on top of Bitcoin, like a logistics business, or it could be a token platform or anything, but it's an application layer thing. And it's hard to see in this slide because this was converted from a white background slide, but around that cloud, the outer ring cloud layer, there's actually like points. And those points are the actual users that connect to your closest application cloud service provider. And so what Tal does is you see that node part. It's blown out into the bottom section where what Tal does, which we run a pool, which is the mining node, and we requisition and also own hash power ourselves. So we have external hash and our own hash, and then we provide something which is like a gateway for all customers, which may be regular retail customers, users, or enterprise customers, which we call MAPI. Well, actually, it's the MAPI that I think is also the name used by other folks, but we call it the Miner API because it's an API for you to get access to the core network of Bitcoin. Now, why is this all important? It's because the Bitcoin network, as originally designed, as everyone here most of you should know, but if you don't know already, and it's very important to burn this slide into your memory. The subsidies which comes in by mining blocks, by producing blocks, these things go away in eventually to zero. So as the subsidy decreases every 4 years or so, the subsidy halves, and unless something happens to compensate the economic value decrease, then you will eventually have no more people running Bitcoin nodes or mining nodes. Nobody's producing blocks anymore because it becomes expensive in costs, either in electricity or manpower, or just sunk capital costs that cannot be recovered. It would be no economic incentive for miners to continue. Therefore, what needs to compensate is, you see the exponential graph going up on that side. That's the transaction fees that need to increase in order to compensate for lost Bitcoin subsidies per block. And that's why we always we like to point out the transition from miners who have a business model which is centered around earning the block subsidy. We need to move to transaction processing, because a transaction processor earns revenue from processing transactions. So we are at kind of the cusp where in the next year or two, if we don't have more miners convert to transaction processors, they'll eventually go to business when the mining reward goes to zero or goes to economically insignificant levels. So that's why we're the first to change to a transaction processing model, and that's why it's very important. At this point, I'm just going to do a quick check to make sure I'm not talking to a dead screen. So I'm just going to see whether you guys are still there.
Yeah, we can hear you, Jerry.
Can you hear me?
Loud and clear, yeah.
Does everybody hear me? Somebody say yes.
I think we've had someone already say they can hear you. Yeah.
Okay, good.
Yeah,
All right, I'll go back to the presentation, because I think when it goes to the presentation, it's dead quiet. So I'm just paranoid that I might be talking to a dead connection. Okay, moving back. All right, next. So the important part about MAPI is that we are putting a public face to what normally is miners who don't have any face. So if you think of what miners do in regular BTC Bitcoin, I mean, they produce blocks, but they passively get the transactions to put into the blocks. In fact, there's no obligation whatsoever for them to put any transactions into the block. Zero. And they are well within their rights to just create empty blocks and earn the subsidy. In fact, the only reason they put transactions in blocks is because transactions pay fees, and presumably the fees are worth some money, and they don't want to leave money on the table. But that being said, and that system works well, fine and dandy, but not having an actual counterparty as your infrastructure provider does present some interesting problems if you're an enterprise. For instance, if you want to treat the blockchain like a back office system, like a ledger that is very much like the same ledger that you maintain internally in-house, but just so happens to be public and scrutable and transparent and immutable and all the good things about blockchain. If you don't actually have some counterparty which is going to be responsible for making sure this infrastructure works as you expect, or that your transactions get onto the ledger, well, then that's a lot of business risk. And this business risk, perhaps if you're a developer or an individual, doesn't matter so much. But if you're an enterprise, that matters a lot, right? And if we ever want the blockchain to be used by banks, by financial service companies, by insurance companies, by lawyers, accountants, anybody who is like a company with that actually needs to have a reliable backend, the data system, then you're going to have a counterparty. And that's why we think transaction processing is a very, very lucrative segment that hasn't been really developed yet. And most miners don't even know about it yet because they're just so happy making money from the block subsidies that they don't care. But that's not going to really help blockchain or Bitcoin, specifically Bitcoin SV, be used by companies that matter. Companies that are outside of the crypto sphere, which is very important for us that the users which are outside of the crypto sphere, people who are outside of Bitcoin and blockchain, those customers are the most important to earn because those customers will be bringing in economic value, which is from the outside the ecosystem. And that's real. That's actually really how GDP is generated, right? You need to bring real money from the outside, not just recycle internal money, which could be gains from crypto, speculative asset appreciation, paper value in companies within the ecosystem and their shares. All of that is not really real value. That's kind of like just inflating a bubble. So we need this outside money. And in order to earn this outside money, we need to earn their business by being reliable and public counterparty to provide their infrastructure. So it's very simple. It's not really rocket science, but just doing this business is very important, and we think this business is going to grow. And that if you saw my CoinGeek presentation, right, the total addressable market for transaction processing is trillions, right? If you think about everything which could be formatted into a transaction. Now, the other thing that we provide is one very key business risk mitigator is by being an actual counterparty, like a one that enters into a contractual relationship with our customers, then all of a sudden we can solve one of the most trying problems that customers or like enterprise customers anyway have when trying to use Bitcoin. It's that the price is fluctuating so much. And if the price fluctuates so much, you can imagine telling your supervisor, if you're in an IT department, you're telling them, I want to change our backend database to use a public blockchain instead. Great. Sounds great. What's it going to cost us? Well, it's going to cost us about 500 Satoshis per byte. Well, great. How much is that? Oh, it's pennies, less than a penny. Okay. But what if Bitcoin price goes up by 100 times? Well, then it's going to be dollars, right? Having that instability and variability in your costs is not a great way of having large institutions adopt your technology, right? So we can provide the simple choice of billing our customers in dollars, pounds, Swiss francs, euros, and that once again is a simple thing that can be done once you have a contractual relationship, and will also make enterprises adopt Bitcoin blockchain as a technology platform, which is what we're trying to do. So that being said, I'd like to talk more about tokens, because that's kind of like the title of the presentation. And so what I'd like to talk about is STAS, which is a token technology which we have filed a patent for. We are in a good partnership and relationship with the developer. And this, we believe, is potentially the killer application for the Bitcoin SV blockchain. Why? Because it's so generic, because it could be used for pretty much anything. It can be used for anything where Bitcoin itself is used for something other than a data ledger, right? So what do I mean by that? First of all, what does STAS stand for? STAS actually stands for, it's a backronym, by the way, substantiated tokens by actualizing Satoshis. So these words are very important. I chose them very carefully. Substantiated means it's a token with substantial value. And actualizing means giving or actualizing the value of a Satoshi, right? Changing it from a unactualized Satoshi, which is what Bitcoin is. Now, what does all that mean? Jumping first to as miners change to transaction processors, right? Very much similarly, a Satoshi can then change into a STAS and vice versa. So this is a very important concept, because this is what makes it different from your run-of-the-mill token implementation or token platform that there are quite a number that you can choose from out there. And this difference makes all the difference. So why is it important that a SAT can be a STAS or a STAS can be a SAT, right? It all goes to back to the utility value of Bitcoin. So let's plot the value of Bitcoin on a spectrum here. On the left-hand side, you have the value of Bitcoins as valued by their monetary value. And on the right-hand side of the spectrum, you have Bitcoins not valued as Bitcoins, but Bitcoins valued as STAS tokens. So starting from the left, right? Currently, right now, at the time I picked the price of Bitcoin is $150. At $150, it takes 6,600 sats to equal 1 cent, right? So it's pretty. 1 cent is it will take 6,000 sats, and on the spectrum, I've marked off the range at which a regular transaction is normally. Like, this is how much a normal transaction in Bitcoin costs to be mined, right? It's somewhere between 100 to 1,000 sats. So you can see that the value of 1 penny is much more than the value of a Bitcoin transaction, or the cost of putting a transaction onto Bitcoin. And that's good. So that's why right now it costs less than, it costs the thousands of a penny around, or 1/6 of a penny, depending on the type of transaction, to put a transaction onto the Bitcoin ledger. But as we move to the right on the spectrum, right, you get different values, right? Right in the middle is an interesting point, because in the middle, if 1 Satoshi were to equal 1 penny, right, that would mean the price of Bitcoins, which is $150, would be 6,000 times, or 6.667 times, 1,000 times more than it is today. That works out to be, about $600 to $500,000, right? I mean, that's effectively what would happen. So if we can either wait for organic use of Bitcoin to be so great that the demand for Satoshis makes it such that the price of Bitcoin, 1 Bitcoin, becomes $500,000, right? By nature, just by use of Satoshis as a money, right? So people are passing Satoshis around as money. This is the dream of bootstrapping an economy on the internet that a lot of folks are working on, and that's a very valid goal. But what if there was another way to bootstrap the value of a Satoshi? In fact, very much so exactly a bootstrap, not an organic growth. Well, you can bootstrap a value of a Satoshi by assigning it a value. And you can assign it a value if you have enough credit or trust in your company that you can back that value of a Satoshi, right? So you can see where I'm going with this. You can basically assign Satoshis as a token if you're a bank, or if you're an airline and you want to issue air miles that are worth a penny or whatever each. Because what you're doing is you are taking the credit value of your company or your bank or your license to issue money as a bank, and whatever legal institutions and licenses and regulations that you abide by, the fact that you're a real company, you can turn that credit value, you can turn that trust in you, because you're a trust intermediary, into value. And you do that by just saying, I have $1 or I have a penny, and for this penny is worth 1 Satoshi. This Satoshi is now equal to 1 penny if redeemed by me, because I am a bank and I'm telling you I have that money. Now, of course, some people may claim themselves as banks, but they're not. But then that's for, as long as it's transparent who the issuer is, then I believe the free market will evaluate issuer quality as appropriately. So you can see that Satoshis now can represent value which is much more than what the free market value of a Satoshi is. So now you have this notion of sats, which are unactualized Satoshis, having a free market value because they are like stem cells. They are generic. They can represent money as themselves. They can do everything. They're not restricted. Then you have Satoshis, which have been actualized and turned into a stas. And stas tokens are restricted. They're issued by somebody. They may have limitations on sending. They cannot be used as a regular Satoshi anymore. They can't be sent. They can't be included in a transaction as Satoshi. They must be valued as a stas. You cannot intermix this Satoshi anymore with other Satoshis into another UTXO because they've been turned into a stas. So think of the actualization of a Satoshi as a reversible burn of a Satoshi, of a Bitcoin. Well, Bitcoin's a Satoshi. And then until it is unburned by the issuer, it must remain that different token that represents that different value, right? And what this allows us now is basically a spectrum that represents 2 separate ways where Bitcoin can acquire value. On the left-hand side, Bitcoin acquires value because people are using Satoshis as money. On the right-hand side, this Bitcoin acquires value because it's being used as a technical vessel by which issuing part companies can take these vessels and then turn them into tokens which have meaning, which have value, that's backed by them. And both of these things will drive the value of a Satoshi, the free market value of a Satoshi. One which is a speculative or a velocity-driven, trade-driven model as money, and the other on the right-hand side as an asset, enabling technical utilitarian method. So both of these methods will drive the price of Bitcoins up, and I believe that will definitely help instead of just allowing the speculative value of the velocity of money value drivers drive the price of Bitcoin up. So I think it is greatly going to help the price of Bitcoin appreciate. Final thing I'd like to talk about is, now that we've introduced stas, how does this all fit together with other token platforms? You'll hear a lot of talk of L2 tokens platforms because that's generally when you write things, your entire logic and your ledger is off-chain. So this is the most common token platform, and it's simple because you're just using Bitcoin as a data carrier, right? Think of Bitcoin as a disk, and you write whatever you'd like to the disk, and your logic, which you need to process your token ledger and everything, your token rules, are all outside, run on a separate, on a separate process, on an EVM or a JVM or something. But the blockchain doesn't know about it. L1 and L0 require a little bit of explanation. L1, Stas is an L0 solution. L1 and L0 are different only by the fact that L1 means that the logic for the token transfers or the token system is on chain. So it is written in Bitcoin script, but it still represents its balances outside of Bitcoin. So you may put the rules for transferring and adding and subtracting balances from public addresses and so forth. But the actual calculation, how a wallet would calculate how many tokens you actually have, it has to have its own logic to do that by reading the Bitcoin blockchain and then doing its logic and then keeping its balances in some sort of specific way. L0 is as close to real Bitcoins as you can possibly get. That's why we say a SAT, it becomes a STAS, and a STAS can become a SAT, because literally it's exactly the same model. Not only is the logic that controls the movement of the stases in Bitcoin script, like L1, but the balance is not really anything that needs to be calculated, because the balance is just a STAS, which is a Satoshi. So you can use wallets and servers and nodes can basically use the logic they already have, which tracks UTXOs, because a STAS is a UTXO, just like a normal UTXO would be. So in essence, what it means is that a UTXO is either a UTXO without a STAS ID, or it could be a UTXO with one and only one STAS ID, because it's the same Satoshi cannot be used for two types of tokens, right, at the same time, because it is locked to one STAS ID when it has been issued or actualized. Until it is unissued and turned back into a Satoshi, it will be that STAS instead of a Satoshi. So that's the main difference, and this difference is huge because it simplifies all the servers and all the wallets a capability to implement STAS versus a proprietary token system. And it also means that any token issued using STAS is immediately interoperable with any other platform out there, as long as they also use STAS. You don't the interface, the upper layer logic, all that can be done on different levels. But as long as the low level, the token representation is using STAS, then the token's existence will always be interoperable. This is, I just went through this myself by speaking to it, but the basic difference between layer null and layer 1 and 2, once again, is because the logic is exactly the same. And this is kind of important because we think that STAS, being such a low-level standard, I would even call it a protocol, it's more like a standard, should be open sourced. And so this leads me to my final slide, or, how do you get involved in this? Well, when we first came into, thinking about how to do this properly, well, these are the kind of things we set off wanting to, our edicts. We didn't want another Ethereum ICO rush, because I think everybody in the space wants to avoid undue regulatory scrutiny, and we want to keep bad actors out. That being said, we don't want to keep good and innovators out as well. So we want to make all the code open source, and very similar to almost the ERC20 mentality, where everybody can do whatever they like and experiment. So what we've worked out is a system where we offer limited commercial licenses to all infrastructure providers, whether that's wallets or developers, and everybody in between. As long as you're not in a business of issuing tokens yourself as your business model, STAS is free for you to use and to profit from, to make revenues from, because you are the ones that we want to start building and providing solutions to folks who are the real customers, who are the issuers, who are the banks, who are the insurance companies, who are the value point card systems, who want to issue tokens. Those are the real customers. And those are the issuers, those are the only points of control we want to exert. And for those issuers, we are thinking about a way to just record who they are, so that if they start acting badly and the authorities start asking questions about who these issuers are, then either us or one of our affiliate partners in a consortium that we're thinking about putting together called the STASCon can basically say, oh, this issuer is this company, and these are their directors. They registered this with us when we gave them the license to issue, and that's exactly, I think, the way to do it. I hope this will be, just walk the fine balance between allowing free innovation while giving enough accountability so that bad actors don't get attracted to our platform, and we only have sort of legitimate, let's not say legitimate, let's just say legal uses of tokenization on BSV. So to end, why does tokens matter to an infrastructure provider like Tal? Simply because the use of Satoshis, any use of Satoshis, legal, valid use of a Satoshi, means more volume. And more transactions means, ironically and paradoxically, the cheaper each individual transaction can be. Because remember that the whole Bitcoin scaling model is transactions that scale exponentially. Like back to that graph, that probably the third graph I showed you. We need exponential growth of transactions. We need trillions of transactions. If we get that number of transactions, then each transaction can remain, a thousandths of a cent. If we don't scale with volume, that's when transactions will have to rise as block subsidies go down. Transaction fees, the per transaction fees will rise. And we don't want that, because we know that is not a scalable model. And that's why we're all here in BSV and not in BTC. So with that, thanks very much. And I'll hand it back to you.
Thanks very much, Jerry. Yeah, that was a really interesting presentation. Lots to take in, I think, for everyone. But we have a couple of questions, so I'm just going to take us into the Q&A mode now. And if you're watching and you haven't submitted a question you'd like to, please do. I think you can still submit the questions. We had a couple of really good ones so far already. But I have some myself as well if there aren't any more. So yeah, the first one here from Mark. Do miners need to be legally and financially regulated companies?
No, I don't think so. I think the great thing about Bitcoin is that there can be a happy mix of legally regulated companies and not, because Bitcoin has an open model, and there is no requirement, and I don't think there'll ever be a requirement for miners to declare themselves and say, like, I need to get a license to mine, or now. I think the same will apply for transaction processors. There's no, IBM doesn't need a license to sell Hyperledger. Corda doesn't need a license to sell, R3 doesn't need a license to sell Corda. So I think there's no licenses required. But, for issuers, there should be. And I think that's where the legal rubber hits the road, really. Because when you start issuing things like financial assets or digital versions of financial assets, that's very much a regulated business. So that's the difference. But I don't think transaction processing or mining is.
Mm-hmm. Okay, interesting. And yeah, it's again that I agree with you. It speaks to the kind of, that's part of the nature of Bitcoin as a competitive system. You don't need to necessarily do any one thing in particular to be a competitor. You just need to compete, right? Yeah, exactly. Okay, great. So the next question, how do I move to the next one? I think here we go. Sorry, yeah. So yeah, the next one is, are BSV transaction processes, such as yourself, making profit on the current block rewards? And maybe I'll add to that as well. Just how do you see the kind of balance between the block subsidy and the transaction fees playing out in the kind of the near and also long-term future?
Yeah. Currently, I think all miners are making some amount of profit. If they weren't, they would just turn off. turn off the machines. It doesn't really make sense to keep machines running if you're losing money. Now that being said, if you have been, say, mining for the last 3 years and you have amassed a huge amount of either bitcoins or fiat because you've changed it, then you can obviously keep mining at a loss for a while until you burn through your treasury. So it depends on how long miners have been profitable. That would determine how long they can mine unprofitably. And I think that's very much what we're seeing a lot of today. And because I think there are some BTC miners who are very borderline, and you can see the market change because a lot of BTC miners were expecting the price to double. I mean, that's kind of like their entire scaling model. The price must double. If the price doesn't double and the subsidy halves, then we are on a downward trend. And it's just a matter of time. And we have to turn this trend around. The only way they can turn it around is by pumping the BTC price higher via whatever means they can get their hands on. So I think that currently, though, they're still profitable. Because the ones that are not profitable have probably gone under. Or they're like borderline because they've traded in a lot of their old models, machines, and doubled down and put some more money into new upgraded machines in the hope that the price will go up. But that question is very dependent on which. Sorry, your question did say BSV transaction processors, right? So, yeah, I think it is profitable. It is profitable. It depends on what machines you run, but you will effectively you would only keep the machines on if they're making money.
Yeah, I get, if I understand you correctly, kind of some of the stuff you were talking about, as being a service provider and not just a hash power provider, effectively, that profit will then be constituted by what you gain in the Coinbase of a block, but also the specific revenue models you get from other things as well. So I think it sounds like you've got a model that is a little bit more diversified already than kind of maybe traditional mining would look like. Is that right?
Yeah, that's exactly right. I mean, the whole point of doing transaction processing is that you make money by mining, and you also make money by processing transactions. So you have two ways of making money, and as one may go down, the other one may go up to compensate it. And they're decoupled too. So, for instance, if we produced X amount of hash, and that produced X amount of blocks a day, right? Let's say, I don't know, let's say 20 blocks a day. If we make 20 blocks a day, it doesn't matter whether or not we have 20 blocks and have to process 1,000 transactions in a day, or 1,000,000 transactions in a day, or a billion transactions in a day. Because as long as there is no scaling limit, right? It's limitless scaling. And of course, there is a limit, but it's pretty darn high right now. We've seen in stress test network, 1 or 2 gigabyte blocks. And a gigabyte of blocks every 10 minutes is, it's at least like maybe 30 billion transactions in a day, right? So we're nowhere near the current limits of scaling. So it's really, we have a huge amount of headroom in the growth of transactions that we can process. And if we just get more transactions, then we just make more money. It doesn't matter. We make this more money with the same amount of blocks. And so therefore, this decoupling of the revenue streams, one dependent on transaction volume, the other dependent on the price of Bitcoin and also the hash power we have. I think it's the most diversified basket that will basically be most profitable in the long run.
Mm-hmm. Yeah, that's really an interesting thought actually about it being decoupled, as you say, from the actual Bitcoin price. That's really interesting. Okay, I think we might have to just move on to the next presentation. Otherwise, but I think there's more questions people will be interested in. But I think, can you just let people know how they can get in touch with Tal if they have anything more interesting, if they're interested in using some of these services you talk about?
Yep, sure. You can contact us at info@tal.com, or you can mail me at jerry@tal.com, or find our website, and we'll actually be probably within a month or so. We're working on some developer tools for folks who want to start looking into STAS, because we do recognize that it is a burgeoning technology. It's sort of new, and there's not a lot of tooling out there. So if you're a wallet developer already, then you can probably jump right in, and we would be happy to give you the license, and you can start working on it and start building your business on top of STAS. But if you're not familiar with how to write your own transactions, like raw transactions, and you're not comfortable with doing that without accidentally losing Bitcoins, then maybe just wait a while, and we'll have an SDK out that you can download, which will do the scary parts of the work for you. And we'll have more announcements in the upcoming month with our strategy with STAS on our website, so you can keep an eye out there.
Okay, awesome. Thanks very much. Well, again, thanks so much for joining us today, Jerry. I appreciate how late it is there for you. So
no worries.
We'll let you go now and get some sleep. But yeah, thanks very much. Really, really appreciate having you on.
Okay. Thanks, everybody. Thanks for giving me time. You guys have a good day.
So yeah, the next talk is interesting. It's I'm sure it'll touch on a lot of the points that Jerry's already mentioned. And just right on cue there, we find Paul Webb joining us. Hi, Paul. How's it going?
It's good, thanks. Yeah, getting late here, but not too bad. Not as bad as our friends.
Not too long to go. Yeah, so just a bit of background to this talk. I met Paul recently, visited his site, and I think that everyone's going to be really interested to see, certainly me as someone who works in the industry and sees things from the theoretical perspective most of the time. It was really intriguing to see the kind of mining side from someone who's implementing it, and some of the practical challenges that Paul's not only been discovering, but also kind of overcoming. And again, I think one of the key words here will probably be profit or revenue, and how that's the most kind of important bottom line for miners. But rather than spoiling the talk, I'm just going to let Paul take it away here. Paul, just let me know if I need to click through the slides for you, or if you're able to do it yourself. But yeah, otherwise, please just take it away.
Great. I'll just wait when I need the next slide. So following on from the last talk, which is really interesting. So we've been looking more, we're an infrastructure provider. I assume we got the first slide up, so Lockdown Project. So we operate a data center in South Wales, been here around 10 years now. Tier 3 does all the usual things you'd expect. Generator backup, we have racks, we have customers that turn up and put the kit in there every day. And our job really in this part of the world is an aggregator. So we have lots of clients that need a small amount of hosting, quarter of a rack, half a rack. We build a reasonable size center. We buy big pipes, we buy all the expensive maintenance guys, and we keep something running. And then for a couple £100 a month, a small provider can turn up and run a business. And we provide networking space, racks, and so forth. So over the lockdown, we started playing with some ideas how we could extend the life of some of the mining kit that we know is out there. And absolutely, as the last speaker said, that kit's getting older, it's getting slower. Very stiff competition from Chinese miners that've got cheap hydropower. So what can we do to keep things running a bit more quickly? And we had a particular requirement. So Jack, next slide. I'll jump quickly on from us. Might come back to this later. We've got lots of badges. Some of the interesting things that are in our sensor. PCI DSS. So we have organizations that are running credit card processing transactions. So actually some of the things from the last presentation may be relevant to us. We've got people doing that with old tech, and maybe good opportunities to build that into blockchain stuff too. So on the Lockdown Project, we'd had some miners already mining in the building, and their top right was actually the racks that they were based in. So fairly high power. They're using Antminers, mostly S9s, various speeds, standard air cooling and standard racks. And we'd inherited this particular customer. He'd grown at home as much as he could. He had about 20 miners, mostly 14.5 terahash miners. But he was running out of power at home. It wasn't practical. It was too noisy. All the stuff everyone probably knows. So first of all, they came to us and said, "Can you host them somewhere?" So we had to do a few things straight off to make that scenario work from a cost point of view. So everyone probably knows that in most data centers, anyone worth hosting in anyway, the power is relatively expensive. And I can tell you, as someone who owns a data center, the reason it's expensive is it's not just power that comes out of the mains, it's power that's been through, it has backup generators, it's been through UPS systems and been conditioned. You probably have dual power paths to the racks. You have expensive PDUs that are telling you how much is being used. It's going back to a data center management system so that you can do the billing. So the reason power is really expensive in a data center is we have to spend a lot of money to actually get it to the racks and all the stuff along the way. So the first thing we did was to rip all of that out, because it doesn't really matter. We get a power outage in this part of the world maybe once every 3 years. We get the odd might get the odd blip, but not enough for anyone to notice. So actually, it's a bit of a luxury, our power outage. We've not had a power outage since we first started operating, but the local grid every 3 years. If you're mining, you probably don't care about that. You're not going to pay twice as much for your power to avoid a small outage every 3 years. So we took that out, connected it straight to the grid. So we had a small number of racks, still air conditioned, still secure, but without conditioned power. Took a lot of cost out of that model. That was running fine, but the miner was finding, with his 28 miners running, some months he'd make a profit, some months he'd make a small loss. Overall, he was probably breaking even over the 12 months that we ran those miners for him, slightly less than 12 months perhaps. He probably broke even, maybe made a small gain, and most of his gains and losses depending on the price of Bitcoin, which was his chosen mining currency. So we started looking at what we could do next. He came to us in the January before lockdown, and said, "I'm thinking of giving this up. I've got a few power bills outstanding. Can we do a deal?" So in exchange for the outstanding power, we took all those the miners off him, and we started thinking about, right, let's spend a bit of time now seeing how we can get some more life out of this kit and how we can make some more power. So the kit that we've got, we set up our virtual mining environment. We use Slushpool, Lazy. We've got a whole bunch of S9s, monitoring software. We did a bit of a tour around various bits of software. BrainOS, we found we bricked a few old miners pretty quickly using that. So finally, we're on Awesome Miner, which seems to work pretty well for us. We get quite a lot of control over the overclocking that I'll come to later. So running S9 miners take about 6 amps each to run, quite noisy. We've had the usual problems with things like hash creep and all that sort of stuff, but we ironed that out, got familiar over a couple of months with making all of that work. And then we went on a conference, a data center conference, which we do all the time. So the picture over the right-hand side is our technical manager, one of our graduate trainees, our finance director. Like a lot of the best ideas, we spent a few days in Dublin, officially at a data center conference, looking at some ideas. And one of the great demos we saw there was immersive cooling, fairly small scale, just a switch in a pool of really expensive 3M liquid, but it gave us some ideas, and we spent a few evenings in Dublin in the bars having a look at maybe what we could do when we got back. So next slide. So hopefully a slide that says Lockdown Project Phase 2. So we began in May. We set up our Awesome Miner. I'll come back to this slide later because there's some interesting numbers on here to point out. And we took the miners, and we had racks of miners like over on the right-hand side, humming away, making loads of noise. We're quite fortunate at our center. We use free air cooling, evaporative cooling. So a lot of the heat, where you've got a real excess heat load, like we had 60 kilowatts coming out of these miners, we just throw that away, just go straight outside. So actually it doesn't stress our systems too much. So the issues weren't operating the infrastructure, it's more to do with the amount of power that these things took. So we started designing. We had a look around, so that you'll see on YouTube, there's quite a few people in various countries got fairly small scale stuff, mostly Eastern Europe. There's a few bits and pieces, fairly good scale, obviously in China. Very, very new industry in the UK. Yeah, very few people to speak to, very few people try this. Even getting hold of some of the raw materials very difficult. So we started from scratch, and we looked at, first of all, we looked at all the various fluids we can use. And anyone that's looked at this, there's a whole bunch of new stuff out, 3M, lots of synthetic type liquids now, horrendously expensive. We had a quick look at those, and it quickly became apparent that using the nice sort of 3M Novik stuff, you know, we never make a profit out of this. Not we mine's the end of eternity. You know, synthetic oil was coming out £80 a litre, and the tank that you see over there on the right hand side of the slide, that takes about 1,400 litres. So way more than any of the hardware we could put in it. So we didn't do that. So we shopped around, and eventually we ended up importing a container load of mineral oil from China. Took us a while, you know, bit of home duty, all the rest of it. But we now have an almost unlimited supply of immersive cooling liquid or mineral oil, £3 a litre, much more sensible. We can replicate baths all day long with this. And then we had a look at, we're getting heat in the bath. Obviously, we put the miners in the bath. It warms up the oil. We have to get the heat out of the oil. So that's what it looked like on day one. And we looked at I gave the guys a bit of a challenge, a really sort of low tech, low cost way of building some cooling technology. We've got lots of really fancy cooling technology for corporate gear, where people are paying a fortune to host their corporate systems. We want something much more cost effective. So that is a car radiator. It's off a Toyota, and it can move 12 kilowatts of heat. Really, really effective piece of equipment, and it costs £12. So we built a cooling array using those, which worked really, really well. And our first design was to recirculate the oil out of the bath through the radiators and back down. Very simple. If you look at the physics, it's by far the most efficient way to do it. However, you're running all sorts of level 2 problems with how that works. So pumps to shift oil are expensive, much more expensive than to shift water. You know, almost every house got a central heating system, and the pump in there will move water all day long. Oil pumps, noisier, more expensive. So we eventually, after a lot of testing, did away with that, and we moved towards a 2-stage cooling system. Water stays in the bath, oil stays in the bath, water stays in cooling pipes, circulates through the radiators, which in our case are up on the roof. And there was a lot of secondary benefits that we got out of this as well. So when you're building something like this, if you spill water, come back 2 hours later, the water's gone. You get water on your clothes, a few minutes later they dry. You do the same with oil, even fairly harmless oil like this is. You know, you've got environmental issues. You can't let it go down the drains. There's nowhere to get rid of it. So you really don't want it splashed on anything. So in the end, it was much easier to keep the coolant in one place, in the tank, just on the miners, and then use water cooling elsewhere. And yeah, we spent a couple of months figuring that out. So next slide, Jack. Picture of the cooling around the roof. So on the roof we have, because we run a data center, it's N+1, so there's 2. There's a front and back identical array. Each one will get rid of 75 kilowatts with the temperature differential. So nice thing about car radiators, when a car runs down a road, say it's generating 100 horsepower, we've got some numbers on here, a third of that power is moving the car, a third of that power goes out the exhaust as heat, and a third of that power goes directly out the radiator. That's why they're so efficient. So good way to start. Also, when we're immersing the miners in liquid, I got some cool pictures later, you can take the fans off front and back, so no noise. Convection in the tank works perfectly well, really well. Takes away 1/3 of the power you need to run an amp miner. So that was a huge saving for us. So we've got a bank of 40 amp miners, and we're going to scale up from there. So of those 40 Antminers, compared with running them just on a desk or in a rack or something, 12, 13 of those effectively free to run, no power cost, because we just take off all the spinning stuff and it runs fine. We put the radiators up on the roof. We're quite fortunate. We're based in Wales. The weather is rubbish most of the time. It's cold and it's wet, so that really helps us. So at the moment, we're getting pretty good cooling, just ambient, but on the back of that array, you can't see, but it's the ones over on the right. We have temperature controlled. So it was thermostat controlled. We're just moving in because we've got PLC programming skills in-house. We're bolting on a Siemens, fairly low cost Siemens PLC controller, and that steps up the fans as the temperature increases or decreases in the bath. And then for the final piece de resistance, we have a water spray system, mist system for the peak of summer. But it's fairly practical. If it gets too hot in summer, we can just turn some of the miners off. And so with Awesome Miner, you can turn on, you can scale them back at get to a certain temperature. So we've built that functionality in, but we don't think we'll need it at the moment. A fairly low cost array that was probably of the order of £200 or £300 to build. That will cope easily with 40 to 50 Antminers running full pelt. So that was great fun. We'll have fun on the roof putting this thing together. So next slide, we've got some pictures inside now of the tank, and this is the tank post cooling loop. And you can see one of the Antminers being prepared to go in there at the moment. So the structure of the tank, it's essentially a big koi carb tank. It's fiberglass GRP, which copes pretty well with everything we threw at it. Inside the tank, we have a custom built aluminium frame, and it's built for two purposes. One, we can bolt Antminers to it and power supplies on the top. So that supports it in the right sort of location where we've got enough head of fluid above and space underneath, so we get good convection. And we've had a bit of a play around with how that works best. Aluminium's also a really good conductor. All of that's bolted together, so it's a giant heat sink as well. So it's absorbing the water, so the heat from throughout the oil. Then bolted to that, we have some water-filled copper loops. So you carefully designed there, so there's no joints in the tank. You do not want to get water in your oil, because the water doesn't like oil, so it tries to find something else to stick to. So if you get water in your oil and you've got an Antminer there, you'll find it on your Antminer. And we did lose one box doing exactly that. So now we've got oil filtration on it, or filtration on the system now too, to keep it clean. So water circulates around the cooling loops there. There's a couple of the central heating pumps with fairly high capacity central heating pumps. So the average central heating pump in a home will pump 60 litres an hour, and these will pump 180. Although we're finding they run pretty fine on probably 80 to 90 litres per hour, and through 4 loops, and we're getting rid of the heat without any problems at all. On the back there, you can see some fairly low-tech probes that we started with. These are the ones being replaced by the Siemens Tech fairly soon. They have a simple probe that goes in the oil, senses the temperature, has a trigger temperature, which goes up to the roof, turns the fans on. Very, very simple. We'll have much finer control in a couple of weeks' time when we make some changes. But the advantage of this course, much cleaner, environmental friendly. Plumbing's really easy. You can even use push fit plumbing. Push fit plumbing running oil through doesn't work. The rubber seals absorb the oil. Expand, everything leaks. It's a real mess. Anyway, enough about my summer. It's slightly less efficient with 2-stage cooling, oil and water, but it works pretty well. You'll see some of the numbers coming up. So here we have a picture of someone you might recognise on the right-hand side, dropping in one of the first miners in the latest tank once we had the water cooling put in. So we're getting an overall reduction, 30%. So that's a saving. So for our miners, I did some quick sums here. So assuming you're paying 13 kilowatts an hour, so you're buying green energy, you can buy it cheaper. But 13 kilowatts an hour, 25 kilowatt saving in the tank that you're looking at there, 365 days a year, 24 hours a day, that's a 30 grand a year saving. Significant difference. The second thing that we've done, if you can have a look at the screen in the middle, so that's an awesome miner with a number of miners there. The top miners, you see they're all, well, 13.5, I think, terahash, most of these units. You see that most of them are running at about 89, 90 degrees. And we've done a whole bunch of playing with the overclocking, and above that, they turn unreliable pretty quickly. And we killed a few. We bought a whole bunch of second user Antminer stuff just to play with, try a few just for fun. So 89, 90, pretty reliable there. Clock up to 95, don't last too long. The one at the bottom, which is it's a Roper unit, the one that we put in, it's only got one working card at the moment. That, when we put it in, the card was running at 4.9. We've clocked it up so far to 5.7. It's still running absolutely fine, no errors whatsoever. So we're going to push it a bit further and see what it can do. The interesting thing about it, with no fans, just in the liquid cooling, it's running, you can see at the bottom there, at 50 degrees. So internal temperature. So it shows how much more efficient the oil cooling is compared with air. Air is a really good insulator. It's a really bad conductor of heat. So we're getting 30% overclocking and almost 50% reduction in heat, which means that unit's going to last forever. So it gives us the ability to take some sort of fairly old equipment, clock it up. So we can take a 14.5 unit, we can clock it up to be a 17.5 unit, and we still run it cooler and make it last longer than it would have done before. And it's really cool to see. Immersing stuff and seeing it run. It's really good, as Jack can testify to. So we're now starting to package this up. So we're scaling this up ourselves. We do some mining. We do make a profit. We make a reasonable profit, actually. We do now, at least. But we're going to package this up as a service so that either we may rent out some of these units pre-installed, or we might let people just post them to us, and we'll drown them and let them run. Our power's fairly cheap. We're a data center, so we buy power in bulk. So our power's fairly cheap, and of course, we can run for 30% less power than you can anywhere else. So we see some opportunities here for the next 4 years, certainly till the next halving comes along. And someone who's got a fairly old Antminer wants to run it a bit longer, then we've got some options to do that. So overall, it's a bit of fun. Yeah, we spent a few £1,000 and quite a lot of men time over a fairly quiet period, learning a few lessons and seeing what works and what doesn't. But yeah, we're pretty comfortable that we've got, we've learned enough lessons now. We know how to do this. It works pretty well. So finally, I think we've got you might see the video running, or it might just be still, but it's quite cool. You can see the convection bubbling up out of the miner on the left, and now that tank's sort of nicely full up, and we're playing with it with anger. So, Jack, back to you. Bit of fun. Hope that was interesting. And if anyone wants any information on the numbers, feel free. Quite happy to share everything we've done.
Yeah, thanks very much, Paul. That was a really fascinating presentation. Obviously, I can attest to how bizarre that is, seeing an Antminer submerged and whirring away mining Bitcoin. It's bizarre. We do have a couple of questions, and obviously, in the audience, if you have any more, it's a good time to keep submitting them and asking Paul. So I'll start the Q&A mode again, so we can just see those pop up. So this is from the previous one. If I just moved here we go. So yeah, the first question: do you have plans to become a supplier of cooling systems, seeing as the market for this could be huge, or maybe license the technology?
Yes, we do. On both cases, actually. So we've skilled up. We've added some members of staff. So one of our first guys, Dmitry, he's actually an ex-Ukrainian physics teacher, really well suited for this stuff, can even do the maths. So yes, yeah, we can package it up. And it was interesting. We spent a lot of time searching for some package solutions to make this work, and really not much in the UK. And you could run this. I think you can make this work from about 4 to 6 miners upwards. You could probably come up with a solution that would work. But a bath like that, end to end, is probably, you could probably do that now for 4 or 5K. You could put 40 miners in it, and you could save 30 grand a year. So it's a pretty clear ROI. If you're into mining, this makes a lot of sense.
Yeah, and also just because that kind of question speaks to the idea of scale. I think Jerry mentioned this as well, but the industry is tending towards, huge Chinese sized mining farms currently. I think that the orders are more like petahash now to be competitive for most of them. So like, do you see your business being someone that ends up being really competitive in this space, and like how big do you see this going for you?
So so we're up to about 500 terahashes at the moment, and practically we probably see that being 10% of what we do. Where are we now? By next summer, I would say we could be 10 times that. So it's a reasonable size. I don't think we'll ever. We don't have our own hydroelectric plant, so we won't be catching up with Chinese with that miner anytime soon. But yeah, I think we can get significantly bigger. And for the next few years, we can make decent money out of that.
Yeah, definitely. I think that's a good view to have on it. I think the next one I'll show you is not such a question, but I just wanted to highlight someone saying this is a crazy story about, and it's amazing. If anyone wants to read, we did a little blog interview with Paul and published this morning, but we highlighted there, and you mentioned you fell into mining by accident, as it says on your website, and it is quite an interesting story you've got. Yeah,
so I mean, the guy who had outstanding power bills, he dabbled with miners. It was a partnership actually with two guys. One was the senior IT guy at British Gas, and the other works for Checkpoint, been there donkey's years. And they sort of pulled their resources and got into it. But it was the old problem. Power's quite expensive. And so it was quite marginal, and they ran it for 9-10 months, I think. And then we gave him his last power invoice, and he just enough was enough. He couldn't wait anymore. He was pretty confident the price would go up again, as it did actually. It went up about 6 months after the halving. 2 months after the halving it raised, so he would have actually been back in the black and doing okay, but he'd given up by then. We had the kit in racks, and it was almost as much. We just couldn't be bothered unracking everything. So I let him off the power bill. It's fine, and we just inherited all the kit. But after that, then it was a bit of fun figuring out how to, where he'd gone wrong, how you could make some money out of it. Yeah, and we're still friends, so it's all good.
Yeah, and so you mentioned the halving there. I was actually going to ask. I was interested to know, kind of, because you're coming. It seems like you're coming at this more just as a kind of raw service provider. How much do you pay much attention to these kind of things, like the halving events and the big kind of those software development things like that? And again, speaking to what Jerry said, do you see how do you see things playing out with halvings in the future? And needing to replace that lost revenue with transaction fees.
Yeah, no, the last presentation was really, really interesting. So, but I think Bitcoin value it isn't going down. I've no doubts about that. It's going to carry on appreciating, and it's going to carry on getting more important. We haven't done a lot of work on different coins yet, different currencies. So that's kind of the next piece. We'll start doing that. But we pay more and more attention now. I guess we're a year and a half into it, so we understand it a lot better. We run our own node, just our public service interest. So yeah, we're going to invest more and more. And I think at some point, I said down in the basement, we have credit card processing going on already. We run infrastructure for that. So actually running infrastructure for this stuff makes perfect sense to us. It's a lot, and we'll be in an unusual place. So this is a great way to build some experience. We've learned an awful lot about the market so far, but we check on graduate students every year. We have PhD researchers here before. So yeah, I think we'll carry on investing in this, and maybe we can provide a bit of a focus for some of the interests, certainly in our local area in Wales. Help build some of the skills pool that we need here.
Yeah, that's very interesting. And also so there's another question here that I think, or an observation really. that I think you and I have spoken about a little bit already. But part of my interest, in particular, in running BSV Wales as a community, is furthering the adoption and use of Bitcoin and blockchain in Wales. And I think it's personally, I think it's an industry that's just waiting to happen here for this very reason. So do you? I guess you have a unique perspective on this because you've done a similar thing. You've located a data center business, which is now becoming a mining business more, for very similar reasons. So maybe if you could just elaborate a bit on that decision making process and your opinion about Wales as a potential center for mining.
Yeah, so I think untapped potential probably sums up Wales very well. There's a lot of raw materials here and very little tapping been going on the last few years. So we bought, and you see on the last slide there. So we took over an asset that was it used to be a substation, power substation control centre, and then the NHS owned it for a while before we bought it. And it had no useful purpose in the world. It's a really solid, incredibly strong concrete reinforced building with massive power, useful for nothing. And it would have just been pulled down and some, a bunch of terrace houses put on it. Complete shame. So it's a good example of one of the assets that we got in Wales. As soon as we saw it, we thought, great, it has some physical challenges, but it's a ready-made data center. 50% of what we would need to do or need to build is already here. Someone did it years ago and spent a significant amount of money doing it. And I think the same applies in a lot of ways in Wales. The university is churning out some good graduates now for quite a few years. A lot of entrepreneurs have moved away from Wales, and particularly in the lockdown, actually come back. So there's a lot of resources here where things can happen. So it's important to pull together the fragments that are there, the sparks that are there, and try and push all that forward. So we did that pretty successfully with the centre. For a long time, we had customers that lived in Church Village who swear blind there wasn't a data centre in Church Village. Craziest thing in the world. And it's taken 10 years to get established and fill it up with important stuff and get all the right accreditations and so forth. But as long as enough people do this, the market will grow. So we see, in the same way that we saw just hosting and virtual server farms as being an opportunity 10 years ago, old hat now. Blockchain and cryptocurrency, lots of things are going to come out of it that aren't apparent today. So we need to invest in skills. We need to invest in infrastructure. We make infrastructure available to local organisations. Most of the IT resellers in Wales have got racks in our building. We've had, we had one customer, web hosting customer. Guy had been unemployed for a while. He bought one server. Him and his partner turned up one day. She had green hair. They rented quarter of a rack for 200 quid a month and started a business. That's what we do. That's what we can make happen. So yeah, in the same way we've done it in traditional stuff, it'd be nice if we can start doing things like that with Bitcoin too.
Yeah, awesome. And yeah, I think another thing I wanted to ask you today is kind of taking some elements of Jerry's presentation about the kind of data services in particular side, because you spend all this money as miners appending blocks to the blockchain. So, there's services to be done with the data itself afterwards. So it seems like you might be uniquely positioned actually to take advantage of what I think is going to be part of the future of the industry, is miners who are providing access to this, things like monetized APIs for data, and giving proof of timestamping of data in the chain and things like that. That could be, because you mentioned just now all these different aspects of blockchain that could be really useful in other areas. Do you have a particular other area of blockchain that you're interested in yourself, and do you more generally see like you becoming a service provider to help these kind of things?
Yeah, so I don't say we've not settled on any areas yet. We're busy building infrastructure at the moment, but we will certainly do what we've done in other areas. So if someone had, and it's going to appear certainly out of the universities and maybe elsewhere, but if someone's got a great idea for a service business around crypto, and they're looking for some infrastructure and they're looking for some help. And in the past, we've even invested. We have capital, we have facilities. We'd certainly be open to talk to anyone doing that, and potentially helping and working together on this.
Right. Well, yeah, we'll make sure our members are made aware of that in the future. All right, just one last question here. I think it's kind of the equivalent in the mining industry of how much is a pint of milk, but what's the typical cost of hosting an S9 in your immersion system? Okay,
so we haven't finalised these yet, so someone's going to kick me for coming up with a number, but I reckon it's probably something like 25 quid a month. I'm guessing we'll have final numbers in about, and it'll depend a bit on the speed of the miner, of course, but we'll have final numbers in about 2 weeks' time now. Actually, it's almost done.
Okay.
But it's going to be a few tens of pounds.
Yeah.
It will be. I'm pretty much guaranteed that in that environment, it will be probably 85% of what it costs to run at home.
Okay. Yeah. So it's pretty significant savings, especially given that the margins are always kind of tightening.
Margins getting really tight now. Yeah.
Yeah. Great. Well, thanks. I think we just actually had one more. Oh, just someone saying thank you very much. So yeah, I think that's a great way to place to end it. Thanks very much for that. It was really, really interesting, and I'm sure people are going to hear a lot more from you and about you in the future. So yeah, without further ado, I'm just going to kind of wrap things up very quickly.
Well, actually, if I could mention just one thing that we are going to add, you'll notice we've got fairly big roofs there. We're going to add solar panel. So we think we can run 50 miners free all day. Once we get with solar panel. So that's our next add-on.
Yeah.
So it won't be 85%, it'll be 50%.
Wow. Yeah. All right. Well, yeah, thanks. Yeah, and we'll hopefully have you again in the future to talk a bit more about what you're doing. Yeah, for everyone else, thank you very much for attending. Just to let you know, these are our channels. You can follow us on Twitter. You can follow us on Medium as well. If you want to learn more about what Paul's been talking about, you can read our interview with him that we published this morning. And more importantly, I'll just draw your attention to, you can join the Meetup group, who you may have come through there to get to the webinar, but it's really good if you want to follow the group and be notified of future events. Just make sure you're signed up on there. And speaking of future events, the next one we're doing is on the 25th of November. It'll be a slightly earlier time of 5 o'clock, and it's on a completely different, now for something completely different, basically, version of the webinar. We're looking at the iGaming industry and how Bitcoin can be used to support that and also improve it in many ways. So we'll have a number of interesting presentations and hopefully a panel as well on that. So if you're interested, this is already listed and live on our Meetup page that I just mentioned. So you can go on there and click your registration already. But yeah, thanks very much again to Paul, and thanks again to Jerry for his presentation. I think they were very, very nice and complimentary of each other. And thanks everyone for joining us. We'll see you next time. Bye.